As previously discussed, inferential tests give us information about significance. For example, is there a significant relationship between two variables at the population level? Are they independent or dependent? What inferential statistics does not tell us is the strength or importance of the difference or relationships. For example, if there is a significant difference, how strong is that difference? If there is a significant relationship, how strong is that relationship? Measures of association can provide us with this missing information. It tells us about three things. Number one, the existence. Is there an association between two variables, yes or no? Two, the strength. How tightly linked are two variables? And three, the pattern. And if both variables are at least ordinal, direction. In this context, the direction is either positive or negative. The variables are associated in a positive direction if an increasing value on one variable corresponds to an increasing value on the other. The variables are associated in a negative direction if an increasing value of one corresponds to a decreasing value of the other. Different measures of association are appropriate depending upon whether your variables are nominal, ordinal, or interval ratio. Today we will be calculating Bivariate measures of association for nominal level variables using SPSS. For this demonstration, we will be using the shortened version of the 2009 General Social Survey data set supplied. SPSS Demonstration 11.1. What's the relationship between income and health? To answer this question, we will run a crosstabs on total household income and state of health. We must first recode total household income because it has too many categories to be used in a bivariate table. First, click Transform from the main menu and choose Recode into different variables. Next, move the variable total household income to the input variable to output variable box. Then type a name in the output variable box. I have chosen Income 4. Click the Change button. Next, click on the Old and New Values button. I have decided to collapse the values of total household income into 4 categories. We are going to want to click the Range button in the Old Value box, put 1 through 6, then in the New Value box, put 1. For the second category, click the Range button in the Old Value box, put 7 through 9, then in the New Value box, put 2. For the third category, click the Range button in the Old Value box, put 10 through 11, then in the New Value box, put 3. For the last category, click the Range button again in the Old Value box, put 12 through 13, then in the New Value box, put 4. Click Continue, then OK, after inputting these recode instructions. We will also recode the variable state of health, similar to the way we recoded the previous variable. Click Transform and then recode into different variable. Next, click the Reset button to reset all specifications in the dialog and sub-dialog boxes to their default state. Move the variable state of health to the input variable output variable box. Give the recoded variable a new name in the outcoded box. I chose health. Then click the Change button. Click the Old and New Value buttons. Click Range values 1 through 3, then Value 1. Then click Add. Then put 4 through 5 in range, and then 2 for the value. Click Continue, then OK. Score 1 means excellent, 2 means very good, and 3 means good. All of this is grouped together under the state of the health variable into a score of 1 on health. On the new variable of health, scores 4 meaning fair or 5 meaning poor under the state of health variable, score a 2 on health. To examine the effect of income on health, click Analyze, Descriptive Statistics, and Crosstabs, and then input health as the row variable and income 4 as the column variable. Click the Cells button and request column and percentages by clicking the box next to the column in the percentages box. Then click the Continue button to return to the Crosstabs dialog box. Also, request a chi-square by clicking the Statistics button, then click Continue, then OK. Inspecting the table column by column, you will see that there is a relationship and that it is of moderate strength. The maximum difference in the bottom row, poor health, is between the lowest and highest income groups. Both variables are measured at the ordinal level, so we can also describe the direction. Is this relationship positive or negative? Remember that in a positive association, high scores on one variable would be associated with high scores on the other, and low scores will be associated with low. In a negative relationship, high scores on one variable are associated with low scores on the other. Looking at the table again, we see that the relationship is negative. As income increases, poor health decreases. The exact probability of chi-square, 0.0, is well below the standard indicator of significant result, 0.05, so we reject the null hypothesis that the variables are independent and conclude that there is a statistically significant relationship between income and health. SPSS Demonstration 11.2. Does criminal victimization vary by area of residence? Another look. In Demonstration 10.1, we use the crosstabs procedure to examine the relationship between ever been a victim of a crime variable and the urban and rural indicator. We saw that the relationship was statistically significant and that persons living in an urban area were more likely than those living in a rural area to have been a victim of a crime. In this demonstration, we will re-examine the relationship and have SPSS compute some measures of association. First, we're going to want to click Analyze, then Descriptive Statistics, and then Crosstabs. Move the Ever Been a Victim of a Crime variable into the row box, and the Urban-Rural Indicator variable into the column box. Click the Cells button and request column percentages. Click the Statistics button and request chi-square, phi, Kramer's V, and lambda. Click Continue, and then OK. And the following output, slightly edited to improve readability, will be produced. The measures of association are reported below the output for the chi-square test. 3 values for lambda are reported in the directional measures output block. Remember that lambda is asymmetrical and will change values depending on which variable is taken as dependent. In this case, ever been a victim of a crime is a dependent variable, so lambda is 0, a value that indicates no relationship between the variables. Looking at the first block in the output cross tabulation, we see, however, that the conditional distributions do change, indicating that there actually is a relationship. The problem here is that the row totals are very unequal, and lambda is misleading and should be disregarded. Pi and Kramer's V are reported in the symmetrical measures output block. The statistics are identical in value, 0.106, as they will be whenever the table has either 2 rows or 2 columns. The measures reveal an association between the variables. However, it's a weak one.